Hello students. In this problem we're going to differentiate this expression up here to obtain f primed minus 2. So this problem is getting you ready for implicit differentiation. Alright, so here we differentiate both sides, and here we're implying that we have some function or some expression or rule, we call it f of x, instead of y. So when we do implicit differentiation, we'll put y's in here, and you could kind of resort to this if you need to, make, procedurally, so that you can obtain f prime of x, which would be dy dx. Okay, but for now I'm just gonna call this a function, or f of x, for this problem. So we take the derivative of minus 20 and we get 0. And then we take a derivative of the sum and we get the sum of the derivatives. But now notice I have x times the quantity f of x cubed, and then I have x multiplied by f of x. So when I take the derivative of this expression, I'm taking the derivative of a product, and same thing here. So when I take the derivative of the product, I have to employ the product rule, and so I'll take the derivative of x, I'll leave f of x cubed alone, plus x left alone times the derivative of f of x to the third power. Alright, so see, I'm taking the derivative of one expression, leaving the other one alone, taking the derivative of the other expression, leaving that first one alone. Then I like to put parentheses around when I'm taking a derivative and I have it's either in a sum or difference. I like to get in the habit of doing that, because if this was a negative sign, then this would have to be distributed, and I want to keep track of this negative one get distributed, and I want to keep track of this sign here and this sign here. So anyways, I just try to get into the habit of putting parentheses. Okay, so then once again I employed the product rule here to get this expression. Derivative of the first term, second term left alone, plus the first term left alone times the derivative of the second term. Then I'm ready to just simply differentiate after I employed the technique of differentiation. And when I differentiate, the derivative of x is 1, that term's left alone, plus x left alone, and then here I have to use the chain rule. 3 times f of x, and then I subtract 1 from the power and I get a 2, and then I have to take the derivative of the inside function, which is f primed, plus, and here I drop the parentheses because the plus 1 distributed through here will not change the sign at all. The derivative of x is 1, f of x is left alone, plus x times the derivative of x, which is f primed of x. So when we get ready for implicit differentiation, these f primed of x's will be y primes or dy dx's. Now I just have to simply solve for f primed of x using a little bit of algebra, and then evaluate at minus 2 up here to get my answer. So I collect like terms. F of x cubed does not have an f primed of x. And f of x does not have an f primed of x next to it, so I collect those two. I'm going to put those two terms together eventually. These two terms do have an f primed of x, and here I just rearranged 3x and f of x squared. And this term has an f primed of x. Okay, so now we're just going to solve for f primed of x using algebra. So I collect the terms that don't have f primed of x together, and I collect the terms with f primed of x, and I factor out the f primed of x. And notice that if I factor out an f primed of x, I'm left with a 3x f of x squared. And if I factor out an f primed of x here, I have an x. And then the next step, that just implies I'm going to take this term over here and move it to the right-hand side. And when I do, there's going to be a negative sign. And then I'm going to divide by this term. So I'll have a negative of the ratio of this term over this term. You'll see that right there. So by moving this term over, I get a negative, and but both of these are negative, so I just grouped them together in the numerator of the fraction. And then in this term, I just divide by that expression. And now I'm ready to determine what f prime of 2 is, negative 2, sorry, in this expression. And I'll do that up here where I have a little space. So wherever I see an x, I put a 2. So I had an x there, so that's f of 2 on the top. That'll be cubed. Then I have 3 times 2, f of 2, quantity squared, plus 2. Once I simplify that, I think those are 2's, so that's going to 8 plus 2 is 10 on the top. 6 times 2 squared, which is 4. 6 times 4 is 24, plus 2 is 26, and I get 10 over 26. Don't forget the negative sign. And if I reduce that fraction, I get negative 5/13. So that is how you solve this problem, right?